Welcome to TechDaily.AI, your source for technical information. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, and disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox cluster, AI servers, and public and private cloud.
That's right. Check out stonefly.com, or you can email your project requirements directly to sales@stonefly.com for more information.
So today we're really diving deep into network segmentation and microsegmentation. We want to explore how these approaches actually work to strengthen network security.
Yeah, we'll break down, the core differences, the pros and cons, and maybe some of those real-world challenges you might hit.
Especially thinking about like a home network setup, which can be surprisingly complex sometimes.
Yeah.
And we'll also touch on how zero trust architecture kind of fits into all of this.
Sounds good. Where should we start?
Okay, let's kick off with the fundamentals. Network segmentation. It's essentially about chopping up a network into smaller, distinct parts, right?
Exactly. The main point is controlling how data flows between those parts, and really crucially, limiting the damage if, say, one part gets breached.
Like digital bulkheads on a ship, almost, keeping a problem contained.
That's a great analogy. And yeah, in a typical home, you might think about grouping things. You've got your main user devices, laptops, phones.
Right. Then maybe a separate zone for guests who visit.
Definitely. And maybe your core infrastructure, your router, switches, and then there's the big one these days. All those IoT gadgets, smart speakers, cameras, you name it.
So each of those groups could potentially live on its own little island, its own subnet or VLAN, maybe even its own Wi-Fi name.
Precisely. The subnet divides the IP address space. A VLAN separates traffic logically. Different SIIs for Wi-Fi, all ways to carve things up.
And the big idea behind doing all this is, well, security first and foremost, restricting who talks to whom and who gets out to the internet.
That's the primary goal. But this is where theory meets reality, and it sometimes gets a bit messy.
Yeah, I was going to say, implementing this, even at home, it sounds straightforward, but devices don't always cooperate, do they?
No, they really don't. So many devices kind of expect or even demand to be on the same subnet or VLAN to function properly.
Like Apple stuff, finding each other with AirPlay or AirDrop, or using a Chromecast?
Exactly, those kinds of things. They often use discovery protocols that just don't work well across network segments by default.
Okay, so that creates some real headaches. Like, where do you put your NVIDIA Shield? You want it to see your NAS for movies. Maybe that's on an infrastructure segment.
Right, but then you might lose the built-in Chromecast feature because your phone, which controls it, is on your main user segment.
Ugh. And Sonos speakers are another classic example. Logically, they feel like IoT devices.
Yeah, you might want them on that potentially less trusted IoT VLAN, but then trying to control them easily from your phone on a different VLAN, that can become a real hassle.
So people must have figured out workarounds, surely.
Well, yeah, the tech community is pretty resourceful. You hear about things like reflecting MDNS traffic.
Yeah.
MDNS is that protocol many devices use for local discovery.
Okay, reflecting it, like bouncing the signal between segments.
Sort of. Or using dedicated MDNS forwarders or repeaters. These tools try to intelligently pass that discovery traffic across the boundaries.
What else?
At your router or firewall, the Layer 3 device, sometimes setting up something called an IGMP proxy, can help manage multicast traffic, like video streams, across segments too.
So these are basically clever tricks to bridge the gaps, letting devices think they're neighbors even when they're in different network rooms.
Pretty much. They maintain functionality while still giving you some separation. And if all else fails, as a last resort,
Yeah, let's say it.
you could start writing firewall rules within the same VLAN. But honestly, that starts to get really complicated really fast.
Yeah, that feels like defeating the purpose a bit. Which brings up a key point, this constant trade-off, right? Between locking things down super tight and, well, actually being able to use your stuff easily.
Absolutely. It's a balancing act. You don't want your network security to be so complex that you can't even use it day to day.
This is where that KISS principle comes in, isn't it? Keep it simple.
Stupid. Exactly. It's tempting to go overboard, especially with home networks. You have to ask why you're doing the segmentation.
Good question. So why do people segment their home networks beyond just the tech hobby aspect?
Well, several good reasons. Just keeping things tidy as you get more devices is one. Scalability, making it easier to manage as things grow.
Okay.
But the big ones are security, limiting the impact if, say, your smart toaster gets hacked.
Heaven forbid.
Right. You don't want it accessing your laptop.
Yeah.
And also privacy, stopping those IoT devices from phoning home or chatting with the internet constantly if you don't want them to.
So it boils down to creating those internal fire breaks, even at home. Okay, that makes sense for network segmentation. But then you hear about microsegmentation. That sounds smaller.
It is much smaller. Microsegmentation basically takes the idea of segmentation and pushes it way further down to the individual workload or even a single application.
Whoa. So not just grouping devices, but putting tiny fences around each specific app.
That's a perfect way to think about it.
Hmm.
Tiny, isolated ring fences.
How?
Yeah.
How is that even possible? It sounds incredibly complex to manage.
Well, this is where modern tech really comes into play. Things like software-defined networking SDN.
Managing networks with software instead of just physical boxes.
Exactly, and virtualization. These allow you to define and enforce these super granular security policies using software, not just physical cables and ports.
And I bet this ties directly into that zero trust idea we mentioned earlier.
Absolutely, it's a core enabler for zero trust. The whole point of zero trust is never trust, always verify. Don't assume anything inside your network is safe.
Right.
Microsegmentation helps enforce that by getting rid of those big, trusted internal zones. Every little piece needs justification to talk to another piece. It's very application-centric.
Okay, so compared to the traditional network segmentation we just talked about, what are the big advantages of going micro?
Several key benefits jump out. First, potentially cost savings.
Really? It sounds more complex.
It can be initially,
Oh.
but because you're relying more on software SDN virtualization, you might need less specialized physical hardware, like multiple internal firewalls or dedicated security appliances.
Okay. Leveraging software over hardware. What else?
Security is the big one, obviously. By having policies specific to each tiny workload, you drastically shrink the attack surface. If one little piece gets compromised,
It can't easily jump somewhere else? The lateral movement is stopped?
precisely, it's much harder for an attacker to move around.
Yeah.
Also get much finer grained visibility and control over exactly what's talking to what. You can be really precise.
Better traffic management, spotting weird behavior maybe?
Yes. And as we said, it's fundamental for implementing zero trust properly. Those strict access controls, that continuous verification microsegmentation is how you actually do that at scale.
Makes sense. And you also mentioned agility.
Yeah, because it's software defined. Adapting your security policies as applications change or scale up or down is much easier and faster than reconfiguring physical network gear. It's just more flexible.
So, microsegmentation. Potentially less hardware costs, definitely tighter security by limiting lateral movement, better visibility, and more adaptable. Sounds powerful.
Especially in complex environments like data centers or the cloud.
Okay, let's circle back properly to Zero Trust Architecture, ZTA. You've mentioned it a few times. It really feels like the philosophical shift driving these more granular approaches.
It really is. ZTA is a cybersecurity strategy, a mindset focused squarely on protecting resources, data, apps, services. The core idea, assume nothing is trusted by default.
So ditch the old castle and moat idea. Secure perimeter, trusted inside.
Completely. That model just doesn't work anymore with remote users, people using their own devices, BYOD, cloud services. The perimeter is porous, if it even exists.
So ZTA says, forget the network location, focus on protecting the actual thing being accessed.
Exactly. Protect the resource itself, not just the network segment it happens to be sitting in.
All right, so what are the commandments of Zero Trust? What are the core tenets?
Okay, there are a few key ones. First, everything is a resource, data, services, devices, accounts. Second, all communication is secured no matter where it originates. Inside the network, outside, doesn't matter.
No more implicit trust for internal traffic?
None. Third, access is granted strictly on a possession basis. Just because you got in once doesn't mean you stay trusted. Fourth, access decisions are dynamic, based on context.
Context
Like the user's identity, the health of their device, the application they're trying to reach, maybe even current threat intelligence. It's not static.
What else?
Fifth, the organization continuously monitors the health and security posture of its assets. Sixth, you authenticate and authorize every attempt to access resources. And seventh, you collect data about access, analyze it, and use it to improve your security posture constantly.
Wow, okay. That's comprehensive. It sounds less like a specific product and more like a whole architectural approach.
That's exactly what it is.
Yeah,
And it involves several key logical components working together.
let's break those down.
Sure. You typically have a policy engine, PE. Think of it as the brain. It makes the final call, grant access, or deny it,
Based on what?
based on the organization's policies, but also inputs from other systems like device health checkers, identity systems, threat feeds. It uses a trust algorithm we can talk about.
Okay, the brain. Then what?
Then there's the policy administrator,
Ah.
PA. It takes the decision from the PE and actually enforces it, telling the enforcement points to open or close the communication path. It might also issue temporary, session-specific credentials.
Got it. And the enforcement point.
That's the policy enforcement point, PEP. This is the gatekeeper. It sits in the path between the user or subject and the resource. It actually enables, monitors, and can terminate the connection based on instructions from the PA.
Like the security guard at the door, checking credentials and letting people through based on the rules from HQ.
That's a pretty good analogy, yeah. The PE and PA are often thought of as being in the control plane, making decisions while the actual user data flows through the PEPs in the data plane.
Control plane for decisions, data plane for the actual traffic. Okay. You mentioned a trust algorithm in the policy engine. How does that work? Is it just a simple checklist?
It can be more complex than that. It's the process the PE uses to evaluate an access request. It pulls together all that context. The request itself, info about the user and their device, the policies for the resource, maybe threat intelligence.
And then decides.
Right. It might be simple criteria: you must meet conditions A, B, and C, or it could be score-based, calculated confidence score, and if it's above X, access is granted.
Interesting.
And it can be singular, each request judged on its own, or contextual, which is more advanced. Contextual algorithms look at the history. Is this user suddenly trying to access something totally unusual for them?
So it can spot weird behavior patterns that might indicate an attack.
Exactly. Contextual algorithms are generally seen as more effective for detecting sophisticated attacks that might otherwise slip through simple checks.
Makes sense. And how do you actually deploy ZTA? Are there standard ways?
There are a few common models. You might have an agent on the user's device that talks to a gateway protecting the resource.
Okay.
Or an enclave gateway that protects a whole group of resources, useful maybe for older systems you can't easily modify.
Right.
Or sometimes a single web portal acts as the gateway for accessing many different resources. And another approach involves running applications in isolated sandboxes on the device itself.
Different ways to put those policy enforcement points in place, essentially.
Yeah, depending on the resources you're trying to protect and your existing infrastructure.
So bringing this all together, for you listening at home or maybe thinking about your workplace, why does understanding segmentation, microsegmentation, and zero trust matter?
Well, whether you're just trying to make your growing collection of home gadgets behave securely or you're involved in enterprise IT, these concepts are really fundamental now.
Those frustrations you might feel trying to get your smart light to talk to your phone across VLANs at home, they're like a miniature version of the huge, complex challenges large organizations face.
Absolutely. And this clear trend towards more granular control, microsegmentation, and the whole trust nothing philosophy of ZTA, it's really a necessary evolution in security thinking. The old ways just aren't enough anymore.
So understanding this gives you a better framework for making security decisions, whether it's choosing how to set up your Wi-Fi or evaluating enterprise security solutions.
Definitely. It helps you think about risk and trust in a more modern way. And honestly, as everything gets more connected, more complex, these ideas are only going to become more critical.
So maybe the next step for you is to just think about your own digital world. What devices do you have? What talks to what? What level of trust do they really need?
Exactly. And for folks in IT, really digging into zero trust principles is becoming essential for designing secure systems for the future.
We've really just scratched the surface today, haven't we? There's so much more depth to the specific technologies, the evolving threats.
Oh, for sure. But hopefully this gives you a solid grounding in the concepts and why they matter. We definitely encourage you to think about how these ideas apply to your situation.
And maybe explore some of the solutions out there, like those from enterprise providers, such as our sponsor Stonefly, who deal with these challenges at scale.
Right.
So here's a final thought to chew on. As we keep moving towards software defining everything and virtualization blurring the lines, what happens when that traditional network perimeter basically dissolves completely? What new challenges and maybe opportunities pop up in a truly zero-trust landscape?